two decimal, right? So we have 110011, comma 111, two decimal. So let's do that one again. So we need this. Okay. So we know we're supposed to take 1, 1. What is it again?
I forgot.
No, you're not the only one. Okay. 110011.
Yeah, double
Yeah,
zero,
one.
double one.
Okay, okay, okay. Let's do this. 1, 1, 0, 0, 1, 1. Then there's a comma. 1, 1, 1. Perfect. So this is how we start. We said we know this is 2 to the power 0, right? Then this is 2 to the power 1, right? So this is everything this side of the comma. Then this is 2 to the power
Two.
2, and then this is 2 to the power 3. This is 2 to the power 4, and then this is 2 to the power 5. So we use 2. We use this, what is it? 2 to the power because it's in binary. If it was in octal, it was going to be 8 to the power something, right? Yeah, so now it's 2 because it's binary. So we're going to start this side. So we know 2 to the power 0. Everything to the power 0 is a
One.
1. Then 2 to the power 1 is a 2. So from going this way, it just doubles. 1, 2, 4, 8, 16, and 32. 32, right? So we know this actually means 1, it means a bit is present, right? So it means this number is present. This one means this number is present. This 0 means this 4 is not present. So it's you can say 1 multiplied by 1, it will give you this. 1 multiplied by 2, it will give you this. 0 multiplied by 4, it will give you 0. 0 multiplied by 8, it will give you 0. 1 multiplied by this, 16. 1 multiplied by this, 32. So you can do that, but in this case, we're just gonna say we know 1 is present, so we're going to have 1 plus 2. 2, we know this bit here is present, right? So
Mm-hmm.
we're going to have 2. It's here, it's there because it's a 1, right? Then here, 0, 4 is not present. It's off. So we're not going to have 4. We're going to have a 0 here. Alternatively, you can just say 0 multiplied by 4. It's up to you. 0 multiplied by 8. So 0 here, it means 8 is not present.
The zero.
Oh, sorry. Yeah, that's a 0. Oh. Okay, then this is a 0 here because it's not present. And then we're going to have a 16 because it's present. And then here we're going to have a 32 because it's present. So 32 plus 16 is 48, plus 2 is 50, plus this one is 51. So we know here the answer is 51, right? Okay, perfect. So on this side of the comma, this was 2 to the power 0, the first one. So going this side is going to be 2 to the power minus 1, 2 to the power minus 1, 2 to the power minus 2, and then 2 to the power minus 3. So everything, half of 1, we know is 0.5, and 2 to the power minus 1 anyway, it's 0.5. So here we're going to have 0.5. And here 0.25, 0.25, and half of 0.25 is 0.125. I have seen sometimes they can even ask you half of this. I had this in the previous session. It's 0.0625, right? If
Yes.
maybe they had another one here, 0.0625. Okay, now we know 0.5 is present because it's a 1, so all these values are present. So it's going to be 0.5 plus 0.25 plus 0.125. So the answer will be 0.5, 0.25, 0.75 plus your, I don't know from there, what's the answer?
0.5.
Let me just see
I
with
think.
my calculator. Oh, but let me see, let me look at the memo. Tell you. The memo says 0.875,
Yes.
0.875. Mm-hmm. So this plus this plus this, but let's see, 0.75 plus this. Yeah, it's 0.875. 875. So your answer is 51,875. Are you with me here?
Yes, yes. This one, I think I got it even from the previous class. Now, my issue was transferring or converting from this binary, this decimal to binary. Because after, if they have like 4 decimals, that's when I get confused of which, like, yeah,
If
how
there are
to
four, this
convert it. Yeah, how to you
four.
see this side on the left hand side, that's something I can convert, right? But on the right hand side, I don't know. I was stuck there to say how
Okay,
can they now
this
convert.
this one's right.
Yes,
You're
but I want,
talking about this one.
it's, now the thing is, I got the question when it was decimal, like this, our answer, and then they say converted to binary to how we actually started.
Oh, all right,
So
all
if
right,
they
all right.
give us like 4 decimal places on my decimal, and then that's when I get confused on how to you know, um, convert it to this to binary.
Okay, okay. So now you're saying if you had, let's say, let's do something easy. If you had 4, comma 875, something like this, you would wanna and then they say convert this to binary, right?
Yeah.
You're
Yes.
saying something like this, okay? Yeah, if you had this is what you do. So it's basically this in reverse order, right?
Okay.
So it's this. Let's start with this side. This side, I need to make it 4.7, 4.875. 4, comma 875, right? So we know before the comma we have 2 to the power 0. So
Yes.
this is max. So just do a step by step like this. 2 to the power 1, 2 to the power 2. Obviously, we know 2 to the power 2 is already a 4. Okay, right? So this side, we're going to have 2 to the power minus 1, 2 to the power minus 2. Let's say you don't know anything about this module, right? 2 to the power minus 3. And then we can say, let's just say 2 to the power minus 4, just to show you that 0.0625. Great stuff.
Okay.
So here, let's just put 2 to the power 3.
Okay.
We know 2 to the power 0 is a 1.
1,
2 to the power 2,
2,
2. 2 to the power 2, 4. 2 to the power 3, 8.
8.
So we know we don't need this 8 anyway. Okay. Then here we know this is 0.5, right?
Yes.
0.5. Then this is 0.25, 25. Then this is 0.125, 1, 2, 5, right? And then this will be
0.
0.0625,
25.
0.625, 0.0625, yeah, 0.0625. Great stuff. We know that here now we look for the numbers that we need, right? So 4, which one is the easiest? We start with the biggest what number here. 8 minus, what is it? 4, sorry, here. 4 minus 8, it's negative. So we don't need this. We already see that we're looking for 4. So this bit makes a binary 8. So we don't need that. We need this one, right?
Yes.
4 into 4. So we need this bit to be 1, right?
Yes.
Then we already have a 4, so this one can be a 0,
0.
right?
0.
And then this one can be a 0. Do you agree?
Yes.
All right. So now this side, we have 0.875. We need to minus 0.875 with 0.5. If we minus it, let me do it, 0.875, we're going to have 0.375, right?
Yes.
So we know we need this. So we just said 0.875 minus 0.5. Then we had, what was left? I have it, one of the examples somewhere. We had 0.375. 0.375. So from there, let me do it here on the side for you. 0.8.
375.
Okay, sorry, 875 minus 0.5, which is the first bit. 0.5 is equals to 0.375.
375. 75.
375. Okay, great stuff. So we know we need a 1 here. So now the second one, if we're going to use it, is going to be a 0.25. So we know 0.375.
Minus 0.25, ne?
Yes, minus 0.25.
Is equals to 0.125.
Exactly. So because we're using 0.25, we're going to put a 1 here, right?
Yes.
It's equals to 0.125. And now 0.125 minus 0.125 is going to be 0. So we're going to need this, right?
Yes.
1, 2, 125 minus 0.125 is equals to be a 0. So we know that we use 0.5, we use this, we use 0.25, we use 0.125. So it's this. So this is that answer basically in binary, back to binary.
Okay, got it.
Understandable. So the secret is this step. So this you can't miss, this you can't miss, and this you can't miss,
Yeah.
right? Then from there you just subtract this with this here, and then put the 1 only on the values that you need. That will make up this total.
Okay.
Here, subtract, put the 1 only on the values that you need. That will make up this total. Understandable?
Got it.
All right, all right, all right. Okay, let's check the next one. I think the next one was. Sorry, I have to. I have. Yeah, this one. Okay, so that one you happy with it? Did you talk about the converting to hexadecimal? Which other one did you struggle with? Let's see from here then. Do you want to do converting to hexadecimal, or you want to do convert this to decimal? Which other one do you want to do? Or must I just go on?
Yeah, you can just go on because I think from even the previous lesson, the other stuff I got, I was able
Oh,
to do them. Yeah, but we can just go on with whatever examples they do.
all right,
Okay,
all right.
so can I just ask, ne, based on the example that we did just up there, ne, that two, uh, you said from the last class that it's like it's going to be binary. It's telling us that it's binary.
Yes.
That's our signal. So even if the two was by the third digit on the yeah, on the right, we're going to just drop it off and focus on the number like besides the two.
Yeah, okay, yeah. With binary, it will only be ones and zeros. There
Oh
won't
yeah,
be any other
okay,
number.
okay, yeah, I
Yeah.
remember. All
So
right, got
it
it.
will only be ones and zeros. Okay, one thing that I wanted to it's just that I've never seen how your assignment one looks like. Is it uploaded?
Yeah, it's even due on next week, Monday.
I know it's true. Where do you guys get it? Let me just see if I have, please, maybe my UNISA interface is a bit different. Let's see. Let's see quickly my modules. Where is it? So you guys see this, and then from here, where do you go? Additional resources or unit one?
Just going to tell you now. I think it's by quiz.
Oh, okay.
Assessment.
Assessment one.
Yeah.
Uh-huh.
Check two.
Maybe assessment one in the meantime. Available from 3 April. Is it a quiz?
Yeah, it's a
Yeah.
quiz.
I see now. It's a quiz. Convert to hexadecimal, so we can look at converting to hexadecimal. Convert octal number to decimal, we can look at octal. Convert decimal, this you are able to do. Flop, Google, convert binary to hexadecimal. This we touched, so we're gonna convert to hex quickly. Then octal number to decimal, it's not a problem. Then this you are able to do to binary. Fraction binary, this you are able to do. This is based on, is based on, you know, decimal value of this you are able to do. How many inputs of a 4-input AND gate must be high in order for, we touched this a bit when we talked about gates. We can look at, we did the truth table in the first session. How many unique symbols in a decimal? I said this without knowing. Last time, you know the ones complement, you know the twos complement, ones complement, basically the inverse, twos complement inverse, then you add one, BCD. Yes, I wanted to touch on this. BCD, binary coded decimal, the output of O, you know, what does the O do? It's in the previous video. The output of an OR gate is low when, you know, when you add to what, this is that addition. We touched on the addition last week. Okay, this is Excel addition. Okay, everything is pretty much straightforward. Okay, no worries. Let's do this. Let's go back to hex. So now, remember you have the binary system, and then you have the hex 1 0 1. They can say to you, convert this to hex, right? If you convert it to hex, what you're going to do is you're going to group this. You're going to group this into 4s, right? So you group this binary into 4s. Hex is to the power, binary is to the power 2, subscript 2, and then hex is subscript 16. In the first session, I even showed you that 10, like I said, the number 10 is an A, right? It's an A, 10, 11B, 12C, 13D, and then I know 15 is an F, right? 15 is an F. So what you do is you group this into 4s. You start from this page here. You group them into 4s. If 1, 2, 3, so this one will need an extra 0. So it will be into 4 as well. So you just, you know, this one is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, right?
Yes.
So you know the first step, you always put that, right? And then after that, you put the answers. Now 1, 2, 4, 8, right? So all these numbers here, they are 15. They won't be more than 16. So they're actually 16 because it starts with 0, right? Starts from 0. So you start with this one first. 1, this one is present. It's going to be 1 plus 2 is present because it's a 1 here. 1 plus 2. 4, it's not present because it's a 0. So this will be a 0 plus 8. 8 is present because it's a 1. So 8 plus 2 plus 1, how much is it? 11, right? And I said from 10, they become alphabets, right?
Okay.
So 11, it's a B. So we know here we have a B. Everything is to the subscript of 16. All right. So here still we will have 1 of this one. 1, 2, 4, 8. 0 and 0, this will give us a 0. This will give us a 2 plus 2. And then this will give us a 4 plus 4. So 4 plus 2 is a 6. Oh, sorry, let me do this last one. Just for the sake of others. 8 to the 0, this bit is not present. So it means 8 is not present. So this will be a 0. Right. So it's basically 4 and 2, which is a 6. 4 plus 2 is a 6. So our answer will be 6B in this case. So converting binary to hex, what did I do? I grouped into 4s, right? Grouped into 4s because I know is to the power, is to the subscript of 16 here. And then if it was octal, I was going to group it into 3s.
Hello? Hello, sir? Hi, Antoinette. Can you hear me?
Sorry guys, I didn't notice that I was not on Wi-Fi. Okay, so let me see, where did I end off? Okay, I said, remember when we convert to hex, we basically group this into fours. So from binary, when we need to convert to octal, what we're gonna do is we're going to group this into threes, right? So we will have this, group it into three, and then this, group it into three. So we know this is 2 to the power 0, 2 to the power 1, 2 to the power 2, right? Yeah, 2 to the power, what is this? 0. Yeah, 2 to the power 1, 2 to the power 2. Yes, I'm right. So 2 to the power 0, it's always a 1. Anything to the power 0 is a 1. Then this will be our 2, and then this will be our 4. 1, 2, 4. So here we know 1 and 1, this bit is present, so we're gonna say 1 plus 0 and 2, this will be a 0 plus 4 and 1, this will be a 4. Right? So we know this is a 5. Okay. Then here, okay, we know this is a 5, right? 5. So here 1, 2, 4, 0, 1. This bit is not present, so this will be a 0 plus this one, 2. This one will be a 2 plus the 4. This one will be a 6. 4 plus 2 is going to be a 6. So our answer here is going to be 6, 5, base 8. 6, 5, 8. So this is basically this into binary. So another one that I wanted to cover was the BCD, binary coded decimal, right? So to convert to binary coded decimal, I have some notes that I uploaded as well. Let's see. So to convert to binary coded decimal, we convert the binary number to decimal first, right? That's the first thing that we do. We convert it to decimal. Then we convert the decimal number to BCD. So this step we already know, converting binary number to decimal, that we already know, right? Then from there, we're gonna use this one. Let's see, example, we're gonna convert this to binary with this long body method, 29. Then we take this 29 to convert to the BCD. When we convert to BCD, we split this 2 and 9. We'll split them apart. We convert each digit into groups of 4 binary digits equivalent, right? But now remember what we convert. From this, we split it into 2. So we need to convert it to decimal first, and then from there, split it into 4. Then we convert it to binary. Then that will be our BCD, binary coded decimal. So it's a binary system which is coded by a decimal. Okay, I'm gonna do an example. So in this example, we're gonna get, let's convert this. So I saw this is in the assignment or something similar to this. So let's see. Okay, great stuff. So we said we need to convert this first into decimal. We'll have 1, 1, 1, 0, 1, 2, right? So we need to convert this into decimal. So we know this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. We know 2 to the power 0 is a 1. Then 2 to the power 1 is a 2. 2 to the power 2 is a 4. So it's basically everything just doubling up. And then 2 to the power 3 is an 8. 2 to the power 4 is a 16. So it's 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, right? Then from here, we know 1 and 1. 1 is present. So this will be a 1. This bit is present. So this bit is not present. 0 means it's not present. So for 2, we are just going to be adding a 0. And then here, 4 is present, so we add the 4. And then here, 8 is present, we add the 8. And then 16 is present because of the 1, so we add the 16. So 16 plus 4 is 20, plus 8, 28, plus 1 is 29. So the answer is 29. So this 29 is in decimal, right? Then we take the decimal number, we're gonna split it into 4. This basically just like what we're doing with hex, but hex we're taking the binary and splitting the binary into 4. So here we're going to split this into 4 digits, right? So this will be, I'm gonna put the 2 here, and then I'm gonna put the 9 here. 4 digits. Obviously you can write 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Let's just write it so that the ones who don't understand can just follow the same principle. 2 to the power 1, 2 to the power 2, and 2 to the power 3, right? We know this is 1, 1, 1, 2, 4, 8. This is a 3. So this will be 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. 1, 2, 4, 8. All right. So now, it's fine. Let's start with this one since we're always starting on this side. So now we know 9 minus 8 is 1, right? 9 minus 8 is equals to 1. So it means we need this bit. We need this bit. We need an 8. So we're going to set this bit to 1. So now we already have 1. So we say 1 minus, do we say 1 minus 4? Nope, we don't say 1 minus 4 because 4 is big. So we'll put the 0 here. Do we say 1 minus 2? Nope, we don't say 1 minus 2 because it's big. So we'll put the 0 here. Do we say 1 minus 1? Yes, we say 1 minus 1. 1 minus 1, so we need to put the 1 here. Great stuff. So let's go to this side. This side, 2 minus 8. Do we say 2 minus 8? 2 minus. Do we say 2 minus 8? No, we don't say 2 minus 8, so we need to put the 0 here because 8 is bigger than 2. Do we say 2 minus 4? No, we don't say 2 minus 4, so we need to put the 0 here. Do we say 2 minus 2? Yes, we say 2 minus 2 because they are the same. So here we need a 1, right? So 2 minus 2 will give us a 0, obviously. Then we don't need any in this one anymore because we don't have any values left, right? 2 minus 2. Here we had 1 minus 1, which was here. So our answer is this. In BCDC, it's BCD. Sorry, 0, 0, 1, 0, 1, 0, 0, 1. This is the answer in BCD. So this was in binary. We took it first to decimal, then we split it and grouped it into 4s. Its binary value into 4s, 2's binary value into 4 digits, and then 9's binary value into 4 digits as well. So this was our answer. So here we need to write B, C, D. Understandable?
Yes, understandable.
All right, all right, all right. Okay, we covered almost everything. Let me just go back to the gates a bit. So remember I said there's an OR gate. There's an OR gate. These are the inputs, two inputs. So this may be A, input A. So we don't know. A is just a variable. It's a group holder. It's like the word name, right? A name can be Dineo, it can be Mariska, it can be Paul, whoever it is. And then here it's a B. Input one, input B. Then we have an output X maybe. So with an OR gate, if you input a 1 here, let's do the truth table for it to be simple. A, B. So this truth table, it's everywhere. It's everywhere. It's on Google. It's called the truth table. It's on Google. It's on everywhere, right? So the truth table, this is 0, 0, 0, 1, 0, 1. So two inputs have four combinations, right? Four possibilities. 2 to the power 2 to the power 2. 2 to the, yo, what's wrong with my 2? 2 to the power 2, right? So this will be 0, 0, 1, 1, 1, 1. Sharp. So in an OR gate, if the input is 0, 0, the output will be A, 0. If input A is 0 and input B is 1, the output will be A1. If A is 1 and B is 0, the output will be A1. If 1, 1, then the output will be A1. So here we say if one of the inputs in an OR gate, if one of the inputs are high, if they are high, right, the output will be high. High is basically 1. 0 is low, right? 1 means high. High, and then 0, we said it means low. Okay, so now this is the truth table of an OR gate. So we know an OR gate, the output is high when one of the inputs are high, right? So let's go to the AND gate. So this will be A, this will be B, and then we can say this is X. So the truth table again, A, B, X. So this will be 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 here. 1, 1. Sure. So in an AND gate, if this input is 0 and this input is 0, the output will be a 0. If A is 0 and B is 1, the output will still be a 0. If A is high and B is low, the output will still be low. If both inputs are high, the output will be high. So in an AND gate, all the inputs must be high for the output to be high. Understandable? So it means in an AND gate, if one of the inputs are low, the output will be low. You understand? So remember, 1 is high and 0 is low. Okay, guys, I think we have the basics of everything. This combined with that, we will have everything. Let me just touch on one's complement for the last time, but it was in the first session. Remember I said 1's complement is just the inverse of this. So 1, we turn it into a 0, 0, we turn it into a 1, this we turn it into a 0, 1, we turn it into a 0, 0, we turn into a 1, and then this one we're going to turn into a 0. So this is 1's complement, right? 1's complement, it's just the inverse. 1's complement. So now for 2's complement, I said you need to convert something into 1's complement first, and then you add 1 here. So if you add 1 here, then your answer will be 1, 1, 0, 1. You don't need this 0 because it's a 0 anyway. So, but this is 2's complement. 2's complement. Okay, I think we have touched almost everything. Any questions in the last 5 minutes?
No questions on my side. Um, just that a comment, just to say, on my UNISA, I see lately when you respond on your on like say because you've already started the conversation and you're just responding, now we don't get email notifications. I don't know if
Oh,
yeah,
oh,
because you are actually responding on your thing. So I think maybe that's why there's a low number of attendance because people probably didn't.
oh.
So
Okay,
I think
okay.
maybe if you can just start it again if there's a
Start a
new,
new
because
one
I
every time.
yeah, because I didn't get
Mm.
the notification either way if I didn't ask a question.
Oh, all right, all right, all
Yeah.
right. Okay. No, no, I get you. No, I will definitely do that. Okay, I'll put this on YouTube for them as well to have a look. But
Okay.
yes, 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 I'll do that. Yeah, I think the person who's responsible for those things was on leave. I sent her an email, but it said she's coming back on the 3rd. I see the 3rd was already Wednesday. This out of the office reply. It was on Wednesday. Maybe she was still busy catching up, but I'll send her another email, probably, yeah, Monday or over the weekend and try and see. Then, yeah, then we'll take it from there. Okay, guys, good luck with the assignment. If you
Thank
have any questions, please just email them. I know you really can't respond on the chat, yeah, on my Unisa. Just email, then I'll just try and see what we can do, even if we don't need to have another session, but I'll just see what notes can I upload, maybe a similar example on what is this thing on my Unisa. Then everyone can can download it. Yeah, they can download that basic example, which will look the same as more or less the question that you want answered. Is it fair enough?
thank you.
All
Thank
right,
you
all
so
right.
much for your time, sir.
Okay. No, no worries. Let me give you 3 minutes of your time and please enjoy your weekend.
Thank you. You too.
All right, all right, all right. Just
Bye.
cheers.
Okay,
Just
bye.
bye. Stop recording.